How old is the Earth? About 4.5 billion years. And how long has life existed on it? At least 3.5 billion years, maybe even longer. But there's a problem. A big, glaring, paradoxical problem. We call it the faint young sun paradox. Here's the issue. When the Earth was young, the sun was much dimmer than it is today. About 30% dimmer to be exact. With such a faint sun, early Earth should have been a frozen wasteland. But it wasn't. We have evidence of liquid water and early life. So what's going on? Let's break it down. Stars like our sun get brighter as they age. It's because of nuclear fusion in their cores. As hydrogen fuses into helium, the core becomes denser and hotter. This makes the sun brighter over billions of years. So 4 billion years ago, the sun was only 70% as bright as it is now. Earth should have been too cold for liquid water. We're talking average temperatures well below freezing. Think permanent global ice age. But that's not what we see in the geological record. We find sediments that formed in liquid water. We see evidence of early life forms. Earth was warm enough for swimming, not skating. This paradox was first pointed out by Carl Sagan and George Mullen in 1972. Since then, scientists have been scratching their heads trying to solve it. So what are the possible solutions? One popular idea is greenhouse gases. Lots of them. Maybe Earth's early atmosphere was loaded with carbon dioxide. We're talking levels 1,000 times higher than today. That could have trapped enough heat to keep things toasty. But CO2 isn't the only greenhouse gas in town. What about methane? Early life forms, like methane-producing bacteria, could have pumped it into the air. A tag team of CO2 and methane might have done the trick. Some scientists look beyond our atmosphere for answers. Maybe the moon played a role. Billions of years ago, it was much closer to Earth. This would have caused massive tides, generating heat through friction. Or perhaps it's about cosmic rays. Some researchers think the early sun had a stronger solar wind. This could have shielded Earth from cooling cosmic rays. Less cosmic rays, less cloud formation, warmer planet. But what if we're looking at this all wrong? What if the sun itself is the key? Some suggest the early sun might have been more massive. A bigger sun would have been brighter, solving our paradox. But this idea has its own problems. Here's where it gets even more interesting. Earth isn't the only planet with this problem. Mars has its own version of the faint young sun paradox. We see signs of past liquid water on Mars, but how? It's even further from the sun than we are. And Venus? Billions of years ago, it might have been a lot like Earth. Oceans, maybe even life, before it turned into the hellish hothouse we know today. So have we solved the faint young sun paradox? Not exactly. We have a lot of ideas but no definitive answer. It's probably a combination of factors. Why does this matter? Understanding Earth's past helps us predict its future. As we grapple with climate change today, insights from billions of years ago could be crucial. Plus, it's just cool. We're unraveling the mysteries of our planet's childhood. We're piecing together the story of how life began and thrived. And we're doing it by looking at rocks, gases, and stars. The faint young sun paradox is more than just a scientific puzzle. It's a reminder of how resilient and adaptable life can be. It's a testament to the delicate balance that makes our planet habitable. And it's an invitation to keep exploring, questioning, and wondering. So next time you look up at the sun, remember that it tells a story. A story of a young star on a warm planet, of oceans and early life, of a paradox that still challenges us today. The faint young sun paradox shows us that. Sometimes the most intriguing questions don't have simple answers, but in science, the journey to find those answers is often as enlightening as the destination.